Imagine, you are standing in the middle of a lush green forest where giant dinosaurs are still leisurely nibbling on leaves. The sun is still shining brightly in the cloudless sky. And then, a small dot of light appears. In just a few minutes, the Earth will turn into hell. A giant meteorite is rushing towards you. It only takes 10 minutes for the brilliant life to turn into ashes. Dinosaurs are burned. The seas rise as high as mountains. The whole planet falls into cold darkness for years. What happened in that moment? Why did the collision only have a 13% chance of choosing the exact point of destruction? And, if it happened again, today, would humans survive? If you like shocking facts about the history of the Earth, don't forget to subscribe to the channel to discover more mysterious and amazing stories. Part 1. Earth before the meteorite. 66 million years ago, Earth was a completely different world than it is today. There was no ice at the poles. Sea levels were tens of meters higher than they are now. Global temperatures were much warmer than they are today, making the planet an ideal environment for life to thrive. This was the late Cretaceous period, a period when dinosaurs dominated almost every terrestrial ecosystem. Vegetation was incredibly rich. Dense forests stretched everywhere with flowering plants, gymnosperms, and ferns growing in layers. Giant herbivores such as sauropods, long-necked dinosaurs, roamed in packs grazing on leaves from the treetops without worrying about food shortages. Meanwhile, carnivorous dinosaurs like Tyrannosaurus rex and Dromaeosaurids hunted in the open forests, serving as apex predators. In the riverbanks and swamps, freshwater ecosystems flourished with many ancient fish turtles and crocodiles. In the skies, winged dinosaurs like pterosaurs, though not birds, still flew about hunting fish or insects. And in the undergrowth, the first mammals began to appear. Small, nocturnal, quietly adapting to a world filled with giant dinosaurs. They were not yet dominant players in the ecosystem, but they were laying the groundwork for their rise in the very distant future. Most important of all was the stability of the ecosystem at the time. There were no obvious signs of an impending extinction. Life ranged from tropical rainforests to the vast oceans. Phytoplankton, plankton, still thrived, serving as the foundation for the entire marine food chain. On land, plants photosynthesized, continuously regenerating oxygen for the more CO2-rich atmosphere today. However, beneath that peaceful appearance, the Earth was still in motion. Tectonic plates moved slowly, volcanoes still smoldered in some places. But no one, not even paleontologists millions of years later, could have guessed that an alien object was hurtling toward Earth carrying enough power to turn everything upside down. The world of dinosaurs, great as it was just a link in the turbulent flow of the planet. And just a few minutes later, this entire stable ecosystem would be swept away in an unprecedented tragedy. Part 2. Earth before the meteorite. A prosper but vulnerable ecosystem. 66 million years ago, Earth entered the final stage of the Cretaceous period, a period when life on the planet flourished and was the most diverse in geological history. Global temperatures were about 6 to 8 degrees Celsius, higher than today. The climate was hot and humid, and there was no permanent ice at the poles. Rising sea levels submerged most coastal areas, creating rich wetlands, shallow continental shelves, and inland seas. This was not just the age of the dinosaurs, but also the culmination of a complex ecosystem that had evolved over more than 150 million years. On land, dinosaurs not only survived, they dominated. Herbivorous dinosaurs like Triceratops and Ankylosaurus roamed in packs, protecting each other from threats. Meanwhile, predators like Tyrannosaurus rex, which weighed up to 8 tons and stood nearly 4 meters tall, held the top position in the food chain. The predatory behavior and competition for survival between species created a tight ecological network that continued to function without signs of slowing down. In coastal areas and jungles, winged reptiles like Pteranodon flew around in search of fish. In the ocean, bony fish, ancient sharks, and marine reptiles like Mosasaurus thrived. Remarkably, plankton, the tiny creatures that form the basis of the marine food chain, still thrived in the warm waters, helping to sustain the entire ocean ecosystem. Plants also flourished. Flowering plants began to dominate gymnosperms. Ferns, conifers, and large trees formed a dense vegetation on land, providing shelter and food for many species. Thanks to vigorous photosynthesis, the atmosphere maintained relatively stable oxygen levels despite CO2 concentrations being significantly higher than today. The remarkable thing is that although the ecosystem appeared stable, it was extremely sensitive to change. The interdependence of the links in the food chain, from plants to herbivores to carnivores, meant that any external shock could lead to a chain reaction. At this time, the Earth was still in motion. Tectonic plates were slowly drifting, creating new mountain ranges and areas of smoldering volcanic activity. Yet there was no sign of an impending extinction. Life was widespread, from tropical rainforests to the bottom of the ocean, as if the Earth were in a natural golden age. No living thing, be it the largest predator or the tiniest plankton, could have imagined that. A giant rock from space was coming, carrying enough energy to turn the entire planet upside down. And in the blink of an eye, the ecosystem that had thrived for hundreds of millions of years would be almost completely wiped out. Part 3. The meteor crossing, the moment the world ended. It was a normal morning at the end of the Cretaceous period. Nothing was different. On land, dinosaurs were still roaming in herds. In the sea, creatures were still swimming rhythmically. The sky was still blue. But on the edge of space, a meteorite more than 10 kilometers in diameter, the size of Mount Everest, was hurtling toward Earth at a speed of about 20 kilometers per second. That means, in less than 4 minutes, it could travel from London to New York. As the meteorite approached Earth's atmosphere, it didn't just glow like a shooting star. Air friction burned its surface, but with a mass of up to 460,000 billion tons, it didn't slow down. As it passed through the atmosphere, it was like a needle piercing a giant balloon, creating a pressure wave that far exceeded any known nuclear explosion. The impact is estimated to have occurred in what is now the Yucatán Peninsula, Mexico, right in one of the most sensitive locations on Earth at the time, a shallow sea containing sediments rich in sulfur and hydrocarbons. This was no simple random impact. It was a blow to the planet's most vulnerable spot. According to geological simulations, only about 13% of the Earth's surface had the conditions to cause a global extinction if it were to hit. But that's exactly where the meteorite landed. The moment of impact was brief, but its effects lasted for centuries. The impact created an explosion equivalent to more than 100 million megatons of TNT, more than 1 billion times more powerful than the Krakatoa eruption of 1883. The shockwaves spread out in all directions at supersonic speeds, incinerating everything for thousands of kilometers. No living thing within a radius of hundreds of kilometers could survive. All were reduced to ash in an instant. The meteorite carved a crater more than 150 kilometers in diameter and 20 kilometers deep, called the Chicxulub crater. This is one of the largest impact structures identified in the history of the planet. The impact shattered the Earth's crust, compressing layers of rock and sending them flying into the air at tremendous speeds. Debris, including molten rock and ultrafine dust, shot into the stratosphere, covering the sky for weeks afterward. But the horror did not stop there. Much of the debris thrown up by the explosion began falling back to Earth. When they collided with the atmosphere, they heated up and burned like small fireballs. The result was a global firestorm, burning forests causing ground temperatures to skyrocket in a short time. Even places thousands of kilometers away from the impact center were not spared. On the ocean, tsunamis up to tens of meters high were recorded in coastal sediments on many continents from North America to Africa. These giant waves not only swept everything away, but also contributed to the disturbance of geological layers, disrupting extremely sensitive coastal ecosystems. Within a few hours, the Earth turned from a planet full of life into a dead land. The entire ecosystem collapsed. Dinosaurs that did not die immediately in the explosion had nowhere to hide. The sky was covered with dust and smoke, and sunlight could not penetrate. Areas near the equator became scorching hot, while places further away plunged into darkness and cold. The impact was more than just a geological event. It was a transition point between two geological eras, marking the end of the Cretaceous and the beginning of the Paleogene. A unique chemical boundary containing high concentrations of iridium, a rare element of extraterrestrial origin, is still found in sediments around the world today, providing irrefutable evidence of that apocalyptic moment. It was the moment when the asteroid collided not just with Earth, but with the evolutionary history of life itself, and it lasted less than 10 minutes. Part 4. After the impact, Earth switches into total destruction mode. Immediately after the meteorite hit the Yucatán Peninsula, Earth suffered not only a physical impact, but also a series of catastrophic chain reactions that spread across the globe. The shockwave created by the explosion traveled at supersonic speeds, destroying everything within a radius of hundreds of kilometers from the epicenter. The temperature at the impact site reached a level that vaporized even the solid rock of the Earth's crust, creating a column of dust and hot gas tens of kilometers high that penetrated the stratosphere. Within minutes of the impact, Earth faced an unprecedented phenomenon, a global rain of fire. Hot rock fragments that had been thrown into the atmosphere from the explosion began to return to the planet's surface. Friction with the air caused them to ignite as they fell, creating billions of tiny fireballs. Scientists estimate that the heat from this phenomenon could have caused many areas of the Earth, even thousands of kilometers away from the epicenter, to burn at the same time. Ancient forests home to dinosaurs and other creatures were burned within hours. In the ocean, the impact created a series of giant tsunamis. Reaching tens of meters in height, these waves not only spread around North America, but have been recorded in sediments as far away as Europe, Africa, and South Asia. The tsunamis destroyed coastal ecosystems, washed away marine life, devastated coral reefs, and disrupted food chains along the ocean coast. However, the most devastating impact did not come from fire or water. It came from dust and aerosols that filled the atmosphere. Within hours, the sky began to turn ash gray. The ash from the impact, containing sulfur dioxide, SO2 carbon monoxide CO, and soot, rose high into the stratosphere, forming a dense layer of clouds that reflected sunlight. Light could not penetrate, leading to a global artificial darkness that lasted for months or even years. As a result, photosynthesis stopped on a large scale. Plants, which are the main source of food for herbivores, could not produce energy. The food chain collapsed at a rate faster than any other time in Earth's history. Phytoplankton, plankton in the ocean, died en masse due to lack of light. Marine ecosystems, which depended on plankton as a foundation, began to collapse from the bottom up. On land, plants withered, herbivores starved, and carnivores died with them. In addition, the impact in an area containing sulfur-rich sediments released billions of tons of toxic gases into the atmosphere. Sulfur dioxide combined with water vapor to form acid rain, which fell across the planet. Acid rain destroyed remaining vegetation, acidified freshwater sources, and severely affected aquatic life. In many areas, water was no longer safe to drink, and habitats were contaminated on a large scale. The Earth's temperature also dropped sharply after the impact. The thick layer of dust completely blocked sunlight, leading to what is known as the post-impact winter, an unprecedented global cooling cycle. Global average temperatures may have dropped by 10-15 degrees Celsius over several months, causing a sudden cold snap that most organisms could not adapt to. With trapped CO2, the reverse greenhouse effect turned many areas that were once dense forests into dry tundra. The combination of all these factors, wildfires, tsunamis, rainstorms, food chain collapse, acid rain, and global winter, plunged the Earth into an unprecedented state of biological crisis. Within a year of the impact, about 75% of all living species became extinct, including all non-avian dinosaurs, many marine reptiles, invertebrates, and even plankton. It wasn't just a disaster. It was a planetary reset where Earth reinvented itself by wiping everything out. Part 5. The Earth is reborn, the surviving remnants and the rising from the ashes. As the dust settled and the sun finally shone its first light after months of obscuration, the Earth was no longer the same planet. The forests that once covered it were now only charred tree trunks. Fertile lands turned to dead soil. Food chains were severed at the roots, and a host of creatures disappeared completely. But it was in this chaotic scene that life began to re-establish itself. Some plants were the first to recover. Ferns, which can reproduce by spores, quickly sprouted back, covering the scorched land. Winds carried the spores hundreds of kilometers away, helping the ecosystems green again in many places near the equator where temperatures were not so harsh. Ferns not only introduced new vegetation but also produced oxygen, restarting the atmospheric cycle necessary for complex life. Next came seed plants, especially palms and legumes, which were able to survive in low light and poor soil. Thanks to their ability to thrive in harsh environments, they gradually replaced the ancient vegetation that had gone extinct, and at the same time provided the first food source for surviving animals. On the animal side, large creatures, especially dinosaurs with body masses of over 22 kilon, became completely extinct. However, some branches of dinosaurs that evolved into birds, with their small-sized thermal feathers and ability to fly to find food, survived. Modern birds are direct descendants of this group of creatures. Their small size and flexible lifestyle help them avoid most of the worst consequences, such as hunger, cold, and acid rain. Many deep-sea creatures survived. Sharks and small bony fishes in particular, which can survive on limited food and live in the deep sea where temperatures and environmental conditions are more stable than at the surface. Some plankton also returned after a few years re-establishing the ocean food chain. Meanwhile, small mammals, which are nocturnal and burrowing, were remarkable survivors. With their small size, good body heat production, and omnivorous eating habits, they were able to survive severe food shortages. These ancient rodents, over millions of years of evolution, gave rise to a diverse lineage of mammals, including primates and eventually humans. Some ancient reptiles also survived this period, such as turtles and the ancestors of modern crocodiles. The reason for this was their ability to survive long periods without food and their semi-aquatic, semi-terrestrial lifestyle. They could burrow into the mud, escape the heat and dust, or live in water with little change. But the process of regeneration was not quick. It took hundreds of thousands of years for the climate to stabilize, for plants to recover, and for closed food chains to form again. The peak of biodiversity in the Cretaceous only returned after about 10 million years. Large species, rhinoceroses, elephants, blue whales, appeared much later, sometimes up to 15-30 million years after the extinction event. In short, the impact not only wiped out most life, but also created opportunities for new life to thrive. In the space left by the dinosaurs, small species, quiet, flexible, and resilient, emerged. It was a clear demonstration in the darkest hours of the planet life did not disappear. It just transformed. Part 6. If the meteorite had not fallen in Mexico, could the Earth have been avoided? The cataclysmic impact that led to the extinction of the dinosaurs and 75% of life on Earth was not just an ordinary meteorite disaster. Scientists have determined that the Chicxulub meteorite struck a particularly sensitive geological location, the Yucatán Peninsula, where there is a thick layer of sediment rich in sulfur and carbonates. It is this location factor that makes the consequences so severe that they lead to mass destruction. According to geological studies published in Nature Geoscience and PNAS, if a meteorite of the same size had fallen into the deep ocean deserts or bare rock terrains, with little organic matter and sulfur, the amount of dust and toxic gases released into the atmosphere would have been significantly less. That means no global winter, no widespread blackouts, and no massive food chain collapse like we've seen before. Statistics show that only about 13% of the Earth's surface is likely to trigger a planetary extinction event if struck by a meteorite. The Yucatán Peninsula, with its kilometers of sulfate rock, falls into this rare category of global detonation locations. It's this impact on the volatile sulfur layer that causes the release of toxic SO2 gas on a global scale, forming a layer of acid sulfate clouds that obscures the sun for months, killing off entire ecosystems from the ground up. Conversely, if a meteorite hits a deep ocean, like the Pacific or South Atlantic, most of the impact energy will be absorbed by the huge volume of water. While it would certainly still cause tsunamis hundreds of meters high and destroy coastal areas, the amount of dust, ash, and sulfur released into the stratosphere would be significantly less. Without the thick ash clouding the sky, sunlight would still penetrate, photosynthesis would not be permanently disrupted, and the food chain would not be disrupted on a global scale. In such a scenario, it is likely that the dinosaurs would not be completely extinct. Some large species would be affected at the impact site or near the coast, but inland ecosystems, especially herbivores and organisms living far from the impact center, would still have a chance to survive. Extinctions would still occur, but at a regional or local level, not a global reset like what happened. However, that does not mean that Earth would be completely safe if the asteroid hit elsewhere. A massive impact in the deep ocean could trigger a super tsunami that would spread across the globe, destroying most coastal cities and ocean ecosystems. In addition, the rapid release of methane from the seabed could also cause a reverse greenhouse effect, causing the Earth to suddenly warm. But even in that scenario, the mass extinction would be less severe than the Yucatán impact. In addition, some scientific hypotheses suggest that the Cretaceous period had already entered a period of biological decline before the impact. Signs of a decline in species diversity, intense volcanic activity in the Deccan Traps, India, and prolonged climate change could have caused ecosystems to begin to fail. In that scenario, the asteroid would be just the last straw, pushing the Earth from a state of instability to a state of total collapse. Earth's history has witnessed a moment that lasted only a few minutes, but was enough to wipe out an entire era of living things. From a planet full of life, Earth fell into cold darkness and death just because of a meteorite that fell at the right place at the right time. But it was also after the destruction that life rose strongly from the ashes. And today, we, humans, are walking on the legacy left behind by that disaster. What do you think? If a similar meteorite appeared in our time, would technology be enough to save humanity? Leave your thoughts in the comment section below. I would love to hear your perspective. Don't forget to subscribe to the channel so you don't miss out on fascinating science videos, shocking historical facts, and the journey to find answers to the most mysterious things in the universe.